Welcome everyone to this mock lecture entitled Energy Management in Data Centers. My name is Robert Basmadjian and I'm lecturer at Department of Informatics in Clausthal University of Technology. The objectives of this lecture is to show you the need for energy management in data centers, also to highlight how energy management within data centers is achieved. Also, you will understand the different optimization objectives when it comes from energy management within data centers. Also, I'm going to give you a high-level overview of energy management systems. And finally, you will know the challenges behind energy management within data centers. We know that digitization has been pervasive in our life. We use daily social media, such as WhatsApp, Facebook, Skype for communication. We also use digitized systems to do daily businesses, such as e-commerce and e-banking. And with the recent COVID-19 situation, we are more and more relying our life on digitized systems, such as we are doing e-learning, education, online courses through digitized systems. All this, however, necessitates and requires ubiquitous ICT infrastructure, which are hosted within huge data centers. ICT stands for Information Communication Technology. As you can see the picture below, it's an example of a data center which hosts computation resources within enclosures. You can see the enclosures which hosts in shelf-like racks consisting of servers and storage devices. As I said, this is for computation purposes. So that those servers and storage devices communicate with each other, there needs to be some communication infrastructure. These are provided by networking equipment. On the one hand, data centers are providing services for the society, but on the other hand, data centers are huge consumers of energy. In 2014, they consumed around 1.6% of the world's energy consumption. Currently, they are about 3%. And as you can see in the picture to the right, it is projected that by 2030, it will be around 8%. And even there are reports that say that there will be around 25% of the world's energy consumption due to emerging technologies such as 5G and blockchain. Luckily, there exist possibilities and strategies to do energy management within data centers. These can be categorized into two groups. During the construction, when you constructed a new data center, you can choose where to build it, the location, such as very cold weather conditioned countries. You can choose your primary cooling system. You can also choose your primary energy source. But whenever your data center up and running and it is constructed, you can still do energy management, and we call it during the operation. This is by continuous upgrades of your infrastructure from less energy efficient to more energy efficient. And there's a possibility of smart and intelligent energy management, and this is the approach that I'm adopting and I'm presenting it in this lecture. Energy management within data centers is possible due to three main reasons. First, data centers, they are highly automated. They have automated infrastructure, which requires little or even no human being intervention. Second is that sometimes data centers, there are certain periods of time in which their workload is highly flexible. And flexibility is key when we want to achieve or realize energy management. And the third is, in order to provide high availability, high reliability, most of the time the infrastructure of data centers are over-provisioned. And this over-provisioning of infrastructure gives us the possibility to do energy management within data centers. When we talk about energy management, there exist two big objectives, sure, within data centers. So let's start the picture here. It starts all from the infrastructure. We have our data center consisting of ICT resources, as I previously mentioned. Then we have mechanisms, such as from the workload perspective, we have consolidation, workload consolidation, migration, shifting, and we can have dynamic voltage and frequency scaling techniques. Another mechanism is that we can exploit cooling system, uninterrupted power supply, and finally, we have flexible agreements in terms of service level agreements and supply demand agreements. Here comes the optimization, and optimization gets advantage or exploits all those mechanisms so that it achieves two objectives. The one to the left, energy consumption minimization. This is to achieve energy efficiency. And to the right, peak power demand reduction. This is in order to achieve demand side management. Those two objectives I'm going to present you on the coming slides separately. First, let's start with the energy minimization, so to achieve energy efficiency. This is where you can see that there's a high level overview where it all starts again with our lower level is our data center. We have the infrastructure. Here we have cloud computing, supercomputing, traditional computing, three different types of computing or three different types of data centers. On top of that, it has its automation frameworks and tools. And then comes the agnostic orchestrator, whose job is to mediate and make an intermediary between the software solution, or let's say energy management system, and the hardware, which is the lower level, which is the infrastructure. Agnostic orchestrator plays similar role as the one that plays our operating system, which is an orchestrator or with let's say mediator between the application and the user and the hardware, which is our computer. So the agnostic orchestrator, in order to be able to do its energy management, it needs two important components: power demand prediction, which predicts the demand, and the optimizer, which is the one who takes the optimized solutions by consulting constantly the power demand predictor and also getting the service level agreements in order not to breach any performance agreements. On this slide, I'm going to demonstrate you there's a feedback loop and how this feedback loop starts and ends while doing energy minimization. So it all starts with the infrastructure. We have our infrastructure. In the infrastructure, we have our sensors, IoT devices, whose main objective is to sense the environment and to generate raw information. Example of sensing is temperature sensor in order to sense what is the temperature at the outlet or the inlet level of the servers. Also, what is the utilization of the CPU of the processor, and so forth. So the monitoring systems, they always get information, updated information. This is fed back to the optimizer, so that optimizer knows currently the situation of the data center consists of the following workloads, the following temperature, and it asks the power predictor, which estimates what will be if I change the configuration, the current configuration, the demands, so that the optimizer takes the most energy efficient solution. Once the optimizer gets the answer to all type of its questions from the predictor, the optimizer tries to take the most optimal decision in the form of a reconfiguration. And this reconfiguration is sent back, a set of actions, back to the infrastructure. And this is where we start the loop and we close the loop. Just for your information, set of actions can be, for instance, turn off server 1 because server 1 is idle doing nothing and you're consuming energy, right? Or another set of action can be migrate the workload in terms of virtual machine from server 2 to server 3, simply because server 3 is more energy efficient than server 2. Such type of actions can take place and can be taken by the optimizer. The second objective here is to achieve demand side management by reducing the peak demand. And as you can see, this ecosystem is much more complicated and it needs the collaboration of two other entities in addition to the data center. As you can see in the picture here, to the top left, it needs coordination and collaboration with the grid operator. We call it DSO, or distribution system operator. And to the right top, there is collaboration with the IT customer. Those are the ones who are using the services of the data center. For this purpose, there should be a bilateral agreement between DC data center and IT customer. We call it green service level agreements. And there should be a bilateral agreement between the data center and the grid operator. We call it green supply demand agreements. Those two agreements shape how the peak demand can be achieved in the whole ecosystem. For this, data center should be equipped with certain tools. Right? The first thing is it needs to have data center energy management system, the one that I presented it in the previous slides. It needs also hardware management, service management, cooling, and uninterrupted power supply management. Challenges that can be seen, some of the important challenges in order to realize such type of an ecosystem, both to achieve demand side management or energy efficiency. First of all, is a derivation of a generic architecture, system architecture, despite the heterogeneity of the underlying systems. Heterogeneity in the infrastructure, it can have different hardware infrastructures, it can have different communication infrastructure. Some of the systems can communicate through wired technologies, other can use wireless technologies, and within wired and wireless there are different types of technologies, right? So there is a heterogeneity. And also in terms of the implementation, there are different software implementations, programming languages, so there is a heterogeneity. And despite this heterogeneity, there's a need for one generic system architecture. And this is one challenge. Second challenge is the provision of algorithms for optimization and control. And this is where the algorithms, there could be algorithms in which it takes decisions within milliseconds, within seconds, within minutes, within hours. And here the time scale changes. And accordingly, there needs to be algorithms that secure and realize such type of optimizations in due time. Third challenge is efficient, reliable, and dependable processing of information, the data that we have it. And usually we have three different methods: analytical mathematical models, recently with the data-driven artificial intelligence methods, or event-based methods. Fourth challenge is that once we have different systems and once we have now ICT communication, the internet comes into it, then become the vulnerabilities of the internet, of our communication, gets into this grid power system, and this is very dangerous. So there needs to be investigation of safety and security threats that are present within such type of whole ecosystem in which where there's an interaction between the data center on one hand and the grid operator on the other hand, and the customers on the third hand. Future research orientations. We know that more and more renewables are being integrated into our ecosystem of data centers. So one challenge is that we need to have some AI-based forecasting methods in order to predict power generation and demand from renewables and also demand from the data centers. There's a need for new pricing schemes, such as dynamic pricing, in which the prices changes within the course of minutes, 15 minutes, 30 minutes, right? As well as new demand response programs. One of the examples is virtual power plant, in which we try to create one huge virtual power plant by aggregating the distributed energy generating resources. And the final point is that we need to have adaptation of the smart grid architecture model. SGAM is a model in which it was created in order to enable the integration of the systems within the context of smart grids. This is where we need to adapt this architecture model for the case of data centers. Key lessons that you learned in this mock lecture is that energy management is key and important in order to achieve sustainable future. We've seen that data centers have been playing and will be playing even more role in achieving this because of they are consuming huge amount of energy, of the world's energy consumption. And this is due to the new emerging technologies of blockchain and 5G. It's possible, we saw that it's possible to achieve energy management within data centers because of its autonomous systems. And we learned that there are two main objectives. One is to achieve energy efficiency by reducing the energy consumption. And the second is to do demand side management by minimizing the peak demands at the data center site. That's all from my side. Thank you for your attention.